Okay, next problem. You could do a chain. We're actually going to do this two ways. I'm going to do it twice. That this is the same thing as pi times tangent of 1/6 x. And so then using what we have up there, that the derivative of tangent mx, let's see if I can write a little smaller. And so using that the derivative of tangent mx is m secant squared mx, I can just do this problem quote unquote directly. If you're just going to remember that the effect of mx is to multiply by the m, we can do this directly, especially when remember here that that is just a coefficient. Don't need a product rule. Just write it down. So my derivative becomes pi. Just write down that pi. Then the effect of that 1/6 is to multiply by it. Then the derivative of the tangent is secant squared, and my angle does not change. And so I get a very pretty answer of secant squared 1/6. And we'll go back to exactly the way it looked. X over 6. There's the way that I honestly would do the problem. But if you forget about the effect of the m, of that 1/6, or you could do the chain rule. And we used the chain rule above. We just shortcutted it knowing what the effect of that m was. Using the chain rule, my inside function is 1/6 x. Outside is tangent. That pi is still a coefficient. It's still just going to stay there. So then I start on the outside. The derivative of tangent is secant squared. The angle doesn't change. So derivative outside, plug in, plane inside, then times the derivative of the inside. Well, the derivative of 1/6 x is 1/6, and I'll just put that up front. So 1/6 pi secant squared x over 6. And there's the same answer. So you've got, on these simpler ones, you've got some choices. Here's the way I would probably do it, because I've been doing this for a really, really long time. Here's maybe the more beginner's way, recognizing that it is a composition and it is a chain rule. Okay, next one. First do what we always do. Rewrite radicals with exponents. Cube root, same thing as 1/3. And so once I do that, it is obviously a chain rule. I've got an inside function of x squared minus 2x plus 1. An outside function of an exponent of 1/3. And so I do a chain rule. And again, that's 6. That's just a coefficient. Do not need product rule. Just write it down. So I'm just going to write down the 6. And I start on the outside. Exponent of 1/3. I do what I do for exponents. Multiply by the exponent. Decrease the exponent by 1. And I'll fill in the middle in a minute. So derivative outside, and then plug in plane inside. And so the inside is going to be x squared minus 2x plus 1. The most common mistake here is people put the derivative of the inside in there. You want the plain inside. Then the rest of the chain rule, which I'll do in symbols, times the derivative of the inside. Derivative inside. So I've got 2 times x squared minus 2x plus 1 times 2x minus 2, derivative of the inside, and I forgot my exponent here, negative 2/3. And then if you wanted to make it look a little prettier, since the original problem was in radical format, we'll return the answer to a radical format. I need net positive exponents for that, so I drop that exponent down. So it's going to go to the denominator, and then the 3 makes it a cube root, and the square does that to it. And then if you want to distribute that 2 in the numerator, you could, or not, I don't care. And then there are other little games you could play with this one. I wouldn't care about the little games. But I notice this guy here factors. This factors to x minus 1, x minus 1. If I factor out the 2 here, that has an x minus 1. So they're canceling opportunities. I would not expect any of that. This is at most what I would expect. You know, you don't have to play all sorts of games. This is good enough here. Okay, next problem. There's an easy way and a hard way to do this. We'll do it the easy way, and then we'll talk about the trick we're gonna pull here. You only want to do in one special case. We'll actually talk about that first. My form here is a constant over stuff. That's not stuff, that's stup. I don't know why I wrote the word stup. That's stupid. Constant over stuff raised to an exponent. When you have that form, and very importantly, constant in the numerator, 4, 2, whatnot, easiest, rewrite to a non-fraction. No, we'll say rewrite to a non-fraction. So in this case, I'm going to say that's 3x to the 4th minus 8 to the 5th is 4 times 3x to the 4th minus 8 to the negative 5. By doing that, it's now just a chain rule. Up here, if you left it in fractional form, you would have had to done a quotient rule and a chain rule. And there will be times where you do have to use 2 major rules. But by rewriting it, it is now just a chain rule because, very importantly, this is a constant and I don't need a product rule. That's now just a coefficient. I do not need a product rule. And so up here as a fraction, it was a 2-rule problem. Quotient rule for the fraction, chain rule for the denominator, because I have inside and outside functions. But here, it's just a 1-rule problem, just a chain rule, but it's a 1-rule problem because this 4 turned into just a coefficient. Had this been 4x, this would now be 4x, and it would be a product rule. And so it would still be a 2-rule problem, and it would be a harder 2-rule problem because negative exponents are harder to work than positive exponents. So you only want to pull this trick of rewriting to a non-fraction when the numerator is a constant. If the numerator is not a constant, you have made the problem harder. Because if the numerator wasn't a constant, like I said, if this was 4x, not just 4, if this was 4x, then this would be 4x, and it would now be a product rule and a chain rule, and then doing simplification with a negative exponent. And none of us want to do that. So only pull this trick when it's a constant over stuff with an exponent. But now it's just going to be a chain rule. My inside function is 3x minus 8. My outside function is an exponent of negative 5. And so I start on the outside, just write that 4 down. You don't have to do anything with it. Start with that exponent. Do what we do for an exponent. Multiply by the exponent, decrease the exponent by 1. So there's derivative outside. Plug in plane inside. Plane inside. The most common mistake is people take a derivative there. Then the rest of the chain rule times the derivative of the inside. So continuing on, that's going to give me negative 20 times 3x4 minus 8 to the negative 6 times 12x cubed. And so negative 20 times 12 would be negative 240. Yep. X cubed. And since the original problem had a positive exponent, we'll return the answer to a positive exponent. The negative 6 drops us down and becomes positive 6. And so there's my derivative. Now, if you decide to not rewrite it and do a quotient rule followed by a chain rule, you'd get the right answer, but it would take much more simplification on the end to get that final answer. And this would be the answer I'm expecting. Let's end this video.